Okay, in this question, we have several equations to solve. Let's start with A. So we have ln 3x squared equals 8. Always remember, whenever you have logarithm, make sure that you simplify it before you solve any question. So here, this ln 3x squared is the same as ln 3 plus ln x squared, because they're multiplied 3 times x squared, so you can separate them. Notice you cannot bring this 2 down from the beginning. This you cannot do. But now, after you separate the 3 from the x, this will be ln 3 plus 2 ln x. So this now should be 8. And this is easy to solve. So 2 ln x is 8 minus ln 3. So ln x we divide by 2. We get 8 minus ln 3 over 2. And finally, to get x from this this equation, you do e to the power. So e to the ln x equals e to this number, 8 minus ln 3 over 2. But e to the ln x, this is the same as x. So we solved it. So therefore, we can write x is e to the power 8 minus ln 3 over 2, which is, and now we evaluate it with the calculator. Okay, so it is e to the power and the fraction 8 minus ln 3 over 2 equals, yeah, so it's about 31.52. If you're asked to 2 digits, 31.52. So let's check. This is what you claim to be the right answer for x. So you're saying that x is 31.52. So I'm going to keep the number in the calculator. This is our answer for x. I'll square it. I'll multiply it by 3. I'll take the ln now, ln of the answer. And hopefully we'll get 8. Exactly 8. You see, so I checked that this is a correct answer. Good. Now we will erase this. So the answer is here. This one as a formula, and this one if you want to write it as a decimal. If you have both of them as choices, of course, you will choose the accurate one. The more accurate one is the formula. But if you have choices and this is one of them and the formula is not, then of course you will choose this one. But as always, if both of them appear in the choices for you, you must choose the more accurate one, which is this. Remember that the number here is, we approximated it from the calculator. Good. So let's now go to part B. Part B, log base x of 729 equals 6. Remember, this log, if log base a of b equals c, this is the same equivalent as saying that a to the power c is b. If you remember, this is what we call the logarithmic equation, or logarithmic equation, and this is the equivalent exponential equation. Okay, they are equivalent, they are the same thing. So based on this, I'm going now to solve the exercise. It says that here, this means exactly that x to the power 6 is 729. And so notice that x is a base of a logarithm, so it must be positive. Here, when you have power 6, you know, the answer could be plus or minus, but you don't take the minus at all. You will not take the negative here, because negative is not a base of a logarithm. So x will be the 6th root of 729. Of course, it has to be plus or minus, but minus we cannot take it. So we just take the plus. So here you'll do the 6th root of 729. equals 3. So the answer is 3 at the end. And to check, let's put 3 here and see, is it true? Where is the log? It's here. So log base 3 of 729. We wish that the answer will be 6. Let's see, equal 6, correct. So let's go now to the next question. So the answer to this is x equal 3. Now in part C, you have an equation that contains an exponential. So let's first move the negative 4 to this side. So this will mean 3e to the x equals 11 plus 4 is 15. If you want to, you do it like this, 11 plus 4, which is 15. Now divide by 3 both sides. You get e to the x equal 15 over 3, which is 5. So e to the x is 5. Now, of course, you apply ln to get rid of e. Apply ln. So you have ln of e to the x equals ln of 5. But ln of e to the x comes down, and ln of e, this is 1, equals ln of 5. So this here is equal to 1, and so finally x must be ln of 5. And that is our answer. And we can check. We want to put this x back in here and check on the calculator that we get 11 if we put this in the calculator. Let's see. So it's here. I like to check the answers to all the questions. 3e to the power, and now you put ln 5. And then what? Minus 4. And you want this to be 11. And it is 11, and so we're done with this part. Now, part D, it's also nice. It's very similar, by the way. It's very similar to this one. The x here is the base. Here the x is in this one. Notice the difference between the two questions. Here, you know, x to the power 6 equals 729. And here, if you write the equivalent exponential form, it will be 3 to the power 4 equals this radical, 2x plus 1. You take 3 to the power 4 equals what we have within the log. Good. So now, in fact, actually, one thing you can do, and I told you to do it, you can still manage with this, but how about we do this first? I told you to always try to make the logarithm as simple as possible. So this is log base 3 of 2x plus 1 to the power half. Remember, square root is power half. This is equal to 4. And so now this power will go down. And so you'll get half log base 3 of 2x plus 1 equals 4. Okay, now multiply by 2. Multiply by 2 both sides. You get log base 3 of 2x plus 1 equals 4 times 2, 8. And now we can write it. 2x plus 1, the thing within the log, is the base to the power. That is here. So the base to the power equals the inside of the logarithm. And finally, so 2x equals 3 to the power 8 minus 1. And this means that x is 3 to the power 8 minus 1 over 2. And of course, we want to find what this is equal to. It will be a big number, because 3 to the 8 is a big number. So 3 to the power 8 minus 1 equals over 2. 3,280. I'll do it as a fraction. 3 to the power 8 minus 1 over 2 equals 3280. So this is a full number, a whole number. So x is 3,280. You can take this because it's a precise answer. To check it, so we're going to put it back in this formula, the x that we found, this 3,280 80. So let's check. Log base 3 of radical, and then we put 2 times the x that we found plus 1. The x that we found is 3280, and now when we evaluate this, we want to get 4 equals 4. Yes, so great. This means that this question is correct, and we'll go to the next one. So the answer to this question is, you can write it either like this or like this. Both of them are precisely the same answer. Okay, now we go to part E. And in this one, this is a direct one. See, the x now is inside. Look again. Here, the x also was inside, and here the x is the base. So notice that these two are kind of the same question, similar. So you say, and in this case, it's even faster than the previous part, because here you say x will be 5 to the power 2.6. That's very simple. Like, you just write the equivalent exponential form, and you will get the answer immediately. So what is 5 to the power 2.6? Well, let's find it. 5 to the power 2.6 equals, yeah. So this is, of course, we will approximate now 65.66. Okay. And of course, if you have both answers in the choices, you will choose this one. But if you don't have this one, of course, if all of them are approximations, you choose the closest one. Good. So this solves this easy question. And let's check it. Log base 5 of the x that we found, which is 5 to the power 2.6, is 2.6. Good. And now we go to the last one and see how to solve it. In this case, cross multiply from the beginning. So this cross multiply. And let's make this less. Okay, so I'll write it better like this. Cross multiply. You'll get 7 times 1 plus 4e to the 2x equals 63. So this is not an x, it's just times. Okay, so I'll just put it without anything. And now divide by 7 from both sides. So 1 plus 4e to the 2x, if we divide by 7, 63 over 7 is 9. So here divide by 7. Okay, and continue. Subtract 1 from both sides. You get 4e to the 2x equals 9 minus 1 is 8. Divide by 4 both sides. So e to the 2x is 8 over 4 is 2. Now apply ln. So you'll have ln of e to the 2x is ln of 2. Finally, 2x comes down, ln e is 1, so 2x equals ln of 2, and this means that x is half, if you divide by 2, half ln 2. You can even write this as ln of 2 to the half, you put the half inside, and this becomes ln of radical 2. You can have it like this, ln of radical 2 or half ln 2. That's our x for this question. And we want to check it, of course. So let's see in here. Okay, so anyways, ln of radical 2, first we see what it is. Ln of radical 2 is, approximately 0.3466 if you take it to 4 digits. Okay, and now let's replace it back into the equation, the ln radical 2. So here you'll have 63 over 1 plus 4e to the power 2 times x, 2 times, and now we put the x that we found. So what is the x that we found? It was ln radical 2. So I'll put it here, ln radical 2. Close, and we now wish that the answer, of course, is 7. Let's see. I'll click now. Equal. Perfect. Okay, great. And this ends this exercise and ends this problem. And I will stop here.